everyone. Everyone's trickling in. It's great to see so many people attending the event today. I'm Marina. I'm from the BAA, the Birmingham Architecture Association. And if you don't know us, we're a kind of a committee and a group of people interested in all aspects of architecture and design, not just in Birmingham, but nationally. And today you're joined by BA Green, with Matt talking to Pat Borer and the rest of BA Green, but they'll introduce you to what's coming up. But just to let you know a bit about us, so last year we donated about £7,500 to the Architects Benevolent Society. If you haven't checked out their work, please do, especially in these current circumstances. They're really helpful. And other than that, we've got a fantastic lineup of events coming up this year. So sign up to our newsletter to stay involved and follow us on our social media. And without further ado, none of this would be possible without our sponsors. So our patron sponsors, Alamure, and then our friends of the BAA, Allgood, Outro, Ibstock Bricks, Kitchen Gallery, Milliken, Rayners and Taylor Maxwell. And just before I hand you over to Matt, we do have a resilience talk with Dav Bansal from Glen Howe Architects next week. So stay tuned and be great to see you there. And I'll hand you over to Matt Redding. Thanks.
Great. Well, thank you very much, Marina. What an amazing opportunity. So, Pat, if you would join me on the up here. So our amazing presenter today is Pat. For some of you, he needs no introduction, as I can see a few names I recognise in the participants. But for those of you who don't know him, Pat is an architect with over 35 years' experience in designing and constructing green buildings. He has been closely involved with the Centre for Alternative Technology in the design and development of ultra-low energy buildings, passive and active solar heating systems, photovoltaic roofs, benign building materials and technologies, cooperative ways of building and healthy internal environments. He has also constructed and designed a number of self-built houses and was awarded an MBE in 2016 in part of his design of the Wales Institute for Sustainable Education, aka the WISE building, at the Centre for Alternative Technology, and his continued incredible contribution to the Architectural Society. I will ask, if you have questions, please put them in the chat. We will get to them at the end. And Pat, thank you so much for joining us.
Okay, thanks. Yeah, thank you, Matt, for actually 35 years. I'm afraid it's more than 35.
Yeah, I said over 35 years. Right. I figured you know. I know. I'd be polite.
Okay. Actually, I personally don't mind people shouting out because it's very quiet when you're doing a talk. At CAT, when I'm lecturing, I like them to murmur, you know, what the hell is he talking about? Things like that. So do murmur. Anyway,
I will.
So I'll share my screen, which looks like that. Then I go F5 and hopefully, no, it doesn't work. Okay, right. Come on, yeah, there we go. Okay, I'm just going to get rid of the little, all the zoomy stuff which gets in the way. You are screen sharing, I know
yep.
I am.
I can see it clearly.
How do you get rid of that? Anyway, okay, so Matt, the flyer said all materials are bad. I feel it's more a Matt phrase than a Pat phrase. So I've politely called it an approach to materials and construction. And now what we like to do as architects is something like this. That is loads of light, space, commodity, lovely materials that we like the look of and the smell of sometimes. This is what we love doing. Now, interestingly, since this opened 10 years ago, I've done none of it. And that's partly nobody's asked me. Oddly, nobody wanted a rammed earth university. I thought they would pile in, but no. But the reason partly is is since then I've been working on this side of things really. And this learned paper from Nature, as you can scan around that, can see that our human-made mass is now bigger than the overall living biomass. So it brings you to the question of, well, two things perhaps. Have we built enough? Perhaps you could rephrase Gandhi and say, there's enough to satisfy everyone's needs, but not everyone's greeds. Because we have got a lot of buildings and they're in a dreadful state, most of them, in all sorts of ways. And we certainly don't need any more offices. I think that's now become quite clear. But also, do we need any more new houses? Is that actually helping the housing crisis? And so on. So I've been looking, well, that's all the only work I can get, it seems, is renovating, looking at existing buildings, which I hadn't done before 2010. Actually, it's all with new building, self-build, whatever, CAT. But it's rather good. That was one reason. Do we need any more? And this idea of reusing, renovating existing buildings is now becoming much, much more central, I think, to architects' work. And I get a guide because my MArch students at CAT, I think most of the projects now are to do with existing buildings and renovating them and adding bits and so on. So they're sort of thinking ahead, I think. And the second thing is, what are these materials, which is what this talks about. So you look at what they say here, yeah, you kind of agree with it. But on the other hand, if you just take some rocks from a field and build a wall out of them, you're not actually adding to the total sort of mass that humans have made. You're kind of moving things around. So, but if you take some of that stone and burnish in a kiln and you give off carbon dioxide and make cement or lime, then obviously you are having an impact. So that's what we're going to be looking at. So on that, just the first bit of this is on that theme really, the marvelous Baroness Brown, who I must come up to get and talk, part of the Committee Climate Change. And she says this: most of our houses are terrible. And just quickly, if you look at what we think remains to be insulated, well, the standards to which they think they're insulated are really poor. What the definition of insulated cavity walls about U value 0.6, and the Passive House ENERPHIT is 0.35, which seems more reasonable. So there's all them to do, same with roofs, same with solid walls, really. So there's a heck of a lot to do. Not only that, the new buildings we've done, housing and non-domestic, I would say are pretty substandard. They need upgrading, as Baroness Brown says. I love this. Yeah, only available the Help to Buy if their homes are really high quality, because they're not. So one of my hobbies is to break onto building sites and photograph terrible things that go on. And these are local buildings to me. You don't need much breaking in because it's in the country. But you can see here, incredible material like Dow Chemicals Wallmate with nice tongue and groove on it. They don't know what to do on the corners. And this one is just down the road from me, Executive Housing. And it's appalling. Partial cavity fill, extreme thermal bypass, as it's called in Passive House circles. So you may as well not have bothered. Not only that, it's actually dangerous because water can be trapped across the cavity into the building. And that's partly the materials, partly really poor specification and really poor site control. But it's not unusual, this sort of thing, you know, using expanded polystyrene offcuts to stuff in a hole. And this goes on all the time. I'm sure you are aware of it. It's dabs, plasterboard and dabs as a way of making a finish to a block building. But unfortunately, this block work and the brickwork outside of it is not airtight. The wind can whistle through here. And if you don't parge this, that is, cover it with plaster, you get what you can see in this thermal imaging. Basically, your insulation is a sheet of plasterboard. So that sort of thing, well, it just needs stopping. It's really bad. Lots of poor workmanship, specification. One of these is one of my sites, the one on the left. This is the second time they did it. I got them to take it down a third time and do it properly. So, and then retrofit, that can also go wrong. This very terrible report from Kate de Selincourt in Preston, and you can see what's happening. It's just, this is external insulation, which should be good, shouldn't it? Best thing you can do probably to a brick house, but you can see how badly it's been done. Huge thermal bridges here, these cappings going the wrong way, which has ended up the houses looking like this. So, right, so that's what's happening. Now, onto materials. It is actually, some of it, and this is nothing to do with the environment really, this is just good building. And just using the wrong materials, or using the materials badly, I suppose. So this little alarming picture is from Fraunhofer, who brought you Passive House and Woofy and things, and shows what happens. And you take away the most common way of insulating an old building is to stick foam back plasterboard onto the walls. And if that's done badly, and also the material itself is kind of asks for problems, you get mold, and we shouldn't have mold in houses with that, or any buildings. That's a bad thing. And what you've got to do is design it so that you don't get mold. And that's partly the way you build it, of course. If it was airtight, it would be better, but it's probably not. And this may have left a gap between the board and the wall, which is bad, that sort of thing, but also the material itself. So this work done by Joseph Little, who's an ex-CAT MSc student 10 years ago, was quite an eye-opener for me. He looked at, this is in Dublin, so quite a wettish area. He looked at 3 different constructions and what you could do. Looked at it in Woofy, which is this analysis you're probably aware of, where it looks at condensation or what's happening to the wall, in this case, over a period. This is 3 years. And it gets wet, then dries out, gets wet, then dries out. And that traditional buildings work like this. Traditional brick wall gets wet, dries out because you've got fires going and lots of ventilation and so on. Very uncomfortable, but if you insulate it, that doesn't happen. Or if you insulate it with, in this case, phenolic foam, you're stopping it drying out into the house. As a rule of thumb, 80% relative humidity is what you're aiming for. And you'll see in old brickwork, it's terrible. In new brickwork, it's getting worse and worse. And even in the rendered block work, and there's different U values, different humidities, it still is above that 80%, and is rising over the years. And then he did lots and lots of different materials, but this is probably the best one he did, which is a calcium silicate foam, slightly different U values, but you can see that because it's a breathable mineral foam, it dries out in the summer and then gets wet again in the winter. And on average, it's less than 80% in the rendered block work. In the old brickwork, what came out of it for him was that anything that wasn't waterproof, you've got to make waterproof, because old brickwork is soaking wet and you just haven't got a hope of doing it. So you have to apply brick cream or other they're called brick creams generally, Kime products and so on, to improve them. So that's nothing to do with the environmental credentials of Calcitherm or polyurethane foam. That's just good sense. So, as I think it said in the flyer, yeah, design is a Venn diagram and we're looking at materials, but it's also linked to all those other things. And we have also the environment as a general thing we're looking at. So, how do you decide about materials? Just take a sip, hold on. BREEAM, lots of you are probably involved in BREEAM, and it uses these ratings, one of which is materials. The work's gone into this is incredible, fantastic stuff. But somebody at some point has made their own decision, or a group of them, about the relative importance of these things. Now with BREEAM, of course, you can do wonderful buildings, like this is one of the archetype schemes. BREEAM Excellent, fantastic building, nice materials, happy children, and so on. I just thought I'd let you into this, which is John O. Hines, who's Archetype's CEO, whatever you call it, managing director, did this little cartoon of how to achieve BREEAM Excellent. So here he is cycling up with this trailer, which then it's kind of a cynical look at it, but he's done enough of these to know that if you've got all these bits and pieces, biodiversity, cash machine, good street lighting, a bus stop and all that, you've got a much better chance of getting it. If you haven't, then it's difficult. Anyway, going on to materials, BREEAM uses the Green Guide specification. Again, a huge amount of work, tremendous detail. You could say it's like I suppose a mainstream view that promotes best practice, but not necessarily the best practice, maybe. Perhaps it encourages box ticking, I don't know. So when I look at it, and people like me, I look up straw bale and it says A. Hooray, that sounds good. And they've looked at all this incredibly detailed stuff. It's also got something I disagree with, that it's a minus number for kilograms carbon dioxide. Why I disagree with it is that many of my buildings are made of timber and straw and all that stuff, which means it was better to build that I can end up with a negative number overall, which means it was better to build it than not build it. And that is obviously crazy. So I don't think you should do that. You shouldn't allow for the sequestration of carbon in the building. It gives a false view. However, straw bale A, good. And it's made, what's it made from? It's made from sunlight, carbon dioxide and water. Depending on the type of straw, it'll have different inputs in terms of fertilizers. Some of them, like miscanthus, none at all. And then you look at expanded polystyrene, it's A+, and that is just on a very basic level, is that a sustainable thing? No, because this comes from oil, which is, as we know, a rather fraught industry, quite destructive socially and environmentally. And the oil really should be left in the ground. I think everybody's kind of agreed. So how can it be that that is, and maybe somebody can explain to me, but it's just on a very simple level. I look at these things and I go, well, that can't be right. Then I look at aluminium, fantastic material, aluminium, very strong. You can form it into all sorts of things, durable and so on. You can recycle it almost infinitely. And this construction, which is made of aluminium, is an A+. So they obviously think it's good. But to get aluminium in the first place, we know is a pretty awful business. This is just a couple of quotes from stuff that's going on. This is a bauxite, a lake near a bauxite extraction. It's a rather pretty colour, but I wouldn't swim in there, I don't think. I wouldn't live here either in wherever it was this spillage of books of waste from an aluminium factory. So we know it's got problems, so we know we've got to use it minimally. So what do these achieve? Well, it's based on the concept every little bit helps, which it sounds reasonable, you know, a bit of recycling here and so on. Every little bit helps. Surely it's much better that lots of people do a tiny bit than a few hippies like me, ex-hippies, sorry, do a lot. But David MacKay, who unfortunately he died quite young, he was the brilliant advisor to the Department of Energy and Climate Change, wrote Sustainability with Hot Air, says, well, if everyone does a little, we'll achieve only little. And his point is, we've gone past the point where everybody's got to do a little, everybody's got to do a lot because we're in crisis. What do? I read this book, which is 10 years old, 20 years old. And these seem good aims to me. Can we replace non-renewable with plentiful, that is probably mineral or renewable sources? And can we substitute all these harmful chemicals with environmentally friendly alternatives? And can we make it so we can take it to bits easily and reuse it? Sounds pretty good. And then you look in the back of his book and it gives expanded polystyrene as 3, which is bad, and straw bale or straw construction is 1. So I kind of agree with it. So you've got to choose who you agree with, really. There's no one answer. You have to make your own decisions. I'm not going to tell you what to do. There's lots of people who want to tell you what to do. This is brilliant, Living Building Challenge, with their red list of materials, really good. Even the dear RIBA got, I think this is very good, these targets, and these miss out the rest of it, but go to the 2030 using the RICS carbon analysis. I mean, that sounds to me less than 300 is pretty good. So that's great. This has now been out a couple of years, and I hope people are moving towards this. There's also loads of stuff, EOU, which is a thing we used to belong to, 140,000 difficult. So these are alien things that we've introduced to the planet. That's rather irresponsible of us. And so they're analysing which is most carcinogenic and so on. Lots going on. Okay, as a rule, you know, it doesn't have to be that complicated. When did we write this? 22 years ago. It seemed to us that if you use a lot of energy to make something, then it's probably been fairly destructive. There's probably been a lot of pollution and so on. So you should tend towards the right-hand side of this table. This has now been updated using the ICE database. This is what we could get hold of in 1998. So you tend to use building materials down this end. Interestingly, concrete's quite low, you see. That's because it's in kilowatt hours per tonne, but we use tons of it. And cement itself is quite high energy. So actually it's quite a lot. Perhaps I should have done this in cubic meters or something. But anyway, this sort of thing gives you a guide to perhaps we should start this end of things and use this, the left-hand side, minimally. So there's now lots of these things around. Not every architect's firm, but lots of architects are getting into this in a big way, which is great. This is one my students use a lot, Herbert, which is a thing you use with Revit. And this is terrific, uses the ICE database, very clever, which gives you a broad brush approach, which I think is pretty good. So how do we end up at CAT? Well, Peter Harper at CAT gave this idea, which I quite like. It is very broad brush, but that in pre-industrial times, calling everything was low impact, wasn't it? It had to be made of stones and lime and wood. And then as time went on in the Industrial Revolution, we brought in some high performance materials such as glass and iron and bricks and so on. So to make wonderful buildings like this and artist studios in Goldhawk Road, is it somewhere? I know, wonderful things. Anyway, but now, certainly for non-domestic buildings, most of the materials, if you look at them, are pretty high performance, good, but very high impact. And traditional materials, if we can call them that, are used as decoration. So this building in Cardiff, I can't remember what it's called, Millennium something or other, next to the Senedd. If you pop round the back into the car park, you see it's made of steel with a sort of wallpaper of slate, ridiculously, I think, put on the front. I mean, that's not how slate should be used, is it? But anyway, as decoration to show it's in Wales. And that's what most of them are like. Now, what we try and do is to reverse that as much as we can. And, you know, we say 80-20, no idea if that's right. I think the Wise building is probably about 90-10, actually, if you look at it in weight, because rammed earth is jolly heavy. But we reduce, building is not that hard, is it? So you can use a low carbon material to provide most of the bulk. You're just trying to keep the rain out and the heat in, and provide, you know, pleasant places for people to live or work. And then but to make it really good and to give us the internet and lighting and heating and so on, we need some what we call industrial vitamins. So we're not throwing away the whole industrial. We're not going back to living in caves. We take the best of what there is and the lowest impact of what there is and use it minimally to give us the most comfortable, convenient buildings that and that's what we try and do. Right, sounds fair enough, but what are these low carbon materials and what are industrial vitamins? Well, I've just given examples of industrial vitamins. It's pretty obvious. I'm sitting here in front of my laptop with a nice lamp and so on. Those are my industrial vitamins at the moment. I've got a heat pump warming my house up, all that, PVEs. Yeah. So what are the low carbon materials? And it's difficult because glass is high carbon, obviously, fantastic material, it's long-lived, and we can get energy from the sun from it, mostly through daylighting and also through passive solar gain. So where do you put that? Well, I'd put it somewhere in the middle. So this is my range. So it's not black and white, is what I'm trying to say, or green and red. It's a graded thing that you have to make up your mind where things go. It seems kind of obvious that lowest impact materials are those, like I said, with the stone wall, you just move something that's there to somewhere that's more convenient for you. And on the whole, that's a very low impact. Can be quite high if you dig a lot of earth up, but we'll say that's low impact. And then the next might be an organic material that's grown by the sun and uses carbon dioxide and water to make it. So that sounds good. A mono material, that is, it's on its own. You can reuse it again, take it to bits, and so on. And then there are composites, not quite as good because it's very difficult to separate out the hemp from the lime. I've tried it. They're both, you know, reasonable low impact materials. Plywood, using a glue, OSB, sheep's wool has got stuff in it, insulation to stop it rotting and so on. So these are composite materials. And then you're on to rather difficult areas. Lime is probably better than cement, but it's not that good. And then calcium silicate and perlite, probably in the same sort of category. Bricks, as I said, lots of energy goes into bricks, but they're fantastic things. They last for hundreds, thousands of years if you use them properly with a nice soft lime mortar, so you can reuse them. So where does that go? Glass the same. And then, you know, goes on to all important cement, concrete, cement, and then into other materials like metals. Again, you know, fantastic stuff, but some are slightly better than others, stainless steel being better than the other ones. And as long as you can reuse them, you know, why not use them in places where a bit of metal does a huge amount of work? And so you'll see in a minute where I've used metal, steel. And then onto plastics. Well, these are truly alien materials. Well, I suppose metal is too, so cement actually. But these are very, plastics have been so useful. God, they're everywhere and they're fantastic, really. But there are better plastics. So thermoplastics, that is polystyrene and polythene. You can recycle polythene, although it's unfortunately not done very much in this country. Most of it is burnt, I believe, or put into landfill, but you can and in time we'll get round to recycling these products. And the less good ones, which are thermoset, you can't do a lot with them once you've made it into a foam or resin or something. So that's my list. You can do your own. And it's that what we're doing all the time, this iteration between good and bad things and cost and availability and environmental impact. And so you as architects are really good at doing that, so get on with it. And so my choice might be to start from the basics and see how far it takes you to, so at the bottom of my list was stone and wood and things. How far can you go with that? So here's the wonderful Stokesay Castle, and it's made of stone and wood and things. There's some glass in it, which may have been fired in a wood-fired oven, like Hardwick Hall, more glass than wall, that place. They made the glass on site using a wood-fired oven, which I think is brilliant. Anyway, there it is, low impact building, but extremely uncomfortable. We wouldn't like it at all. You need lots of servants and fires and fatty foods and thick clothes, and you don't live very long. And the toilet facilities are not good, as you can see here. Drop it out there. But it's a magnificent building. You can go that far, and then so you have that preference for those, and then this minimal chemical intervention. So lime, which they probably did use in this, glass, as you can see, bricks, and then the other things to make life more comfortable. And of course, the sort of passive house thing, fabric first for comfort, then minimal essential servicing. So you might look at these things: local production, low embodied carbon, non-toxic, avoiding petrochemicals wherever possible, reusing things, minimizing waste, design for the last one is kind of a bit architectural, using real materials, and you know what I mean, that have a vernacular familiarity. So we've grown up over millennia with things like wood and stone. We like them, so use them. And we don't like plastics particularly, or metally things. We haven't got a familiarity with them. And show how things are built, because most non-domestic buildings, there's an external skin of something, there's an internal skin, you have no idea what it's made of. And I think that's rather a failure in the architectural profession, that we no longer show how we build buildings. But that's just a thing that me and David have got. So you can make your choices. Thermal insulation, obviously to the left, are conductivity, better lambda values. And you'll see if you look down, most things are roughly the same, because it's air is the insulator, and air has a certain conductivity. If you want to get better than that, you put in another gas. Used to be CFCs, now pentane and things, which has got half the conductivity of air. So you get these better materials, insulating materials down here. And then I've ranked them just in my sort of way of less benign. So I would start with organic, renewable and inorganic materials, but you can't always use them. You can't, you've got a cavity brick wall, you can't use sheep's wool, but you could use cork. So that's a waterproof, fabulous material, and so on. And you would hear people who make foam say it's better to make oil into insulation than to burn it. I would come back by saying it's better to make it out of insulation, out of sustainable materials, and leave the oil where it is, preferably renewable, so sequestering carbon. And we do need just to reduce plastics use. And I couldn't resist, it's a bit glib, but to talk about Grenfell, because it's appalling. It was so shocking. I was shocked. And so, personally, I think we should have an embargo on these two firms. Don't buy anything from them ever again because they've failed. Anyway, yeah, well, if you use these other insulation materials, of course, it's all going to get fatter, isn't it? Because the thickness of the wall will increase maybe by 1.5 times. But perhaps they're going to get fatter anyway because of passive house and so on. Right. So the second and last bit of this is to look at the WISE building, which we finished 10 years ago, and is like a mini university, really, at CAT, where we have lots of mostly MSc courses, including MArch, Part 2 architecture, public courses, and so on. Yeah, that's it. So what I'm going to do is show you some of the constructions, some which have worked really well, and the reasons why we use them, some which have worked less well, and 1 or 2 disasters, which is always good. So this was our brief, the sort of technical brief, if you like. How am I doing? Oh, I'm there.
You're doing well. You're doing well. Don't worry.
Am I?
Keep going. Yeah.
Okay. Okay. I don't know when I started, so I don't know where I'm going to end. Right. So these are things which included, and they're pretty obvious. This is CAD. So it's pretty obvious we do this. And minimum low impact materials, but really nice for an architect. Use innovative materials. What a client telling you to do that. Take a risk. Great. So we've continued the palette that we have been building up. Timber, homegrown timber, limecrete, and so on. Tried to get good insulation, which we mostly did. It could never be a passive house because of its form factor. It's much too extended if you look at it in a minute, because we like it like that. And the windows as good as we could get at the time when we had ordered them in 15 years ago. But we failed miserably because the windows are not very well made on our air permeability. So this is a cross-section through it. It's made of a timber post and beam frame, glulam frame, with hempcrete, hemp lime, 500mm around the back, everywhere where there's not windows. Yeah, this is why it's one of the rules David and me have, which I think is a good one. Every room should have a view. Doesn't sound unreasonable. So that makes for rather extended buildings. Single loaded bedrooms, for example, rather than the sort of usual motel thing of a bedrooms either side of a dark horrid corridor. So every space should be as lovely as you can make it, really. That means views out. So that gives a pretty poor form factor, but it's pretty good insulation anyway. So it's made of hemp lime, which was the experimental bit. We hadn't done that before. We had done rammed earth before, but CAT suggested they wanted a round lecture theatre, which we thought was a bit crazy, but they are. And the round earth been successful. We did it again. So started from the bottom, hydraulic lime concrete. So that's a lower impact concrete that has an initial set, but eventually carbonates to get strong enough. We didn't need much in the way of foundations because we're on bedrock here and other places slate waste. But where you weren't on that, this is a slate tip at its natural angle of repose. So the least impact way was actually to do some ordinary Portland cement reinforced concrete breakers that are fixed to the bedrock at the bottom, and it's like a ladder leaning on the slate tip, and then build the timber frame off that. There are other ways of doing it, but this was actually the least troublesome. So we got retaining walls, which we did in the traditional Victorian way. So rather than reinforced concrete, it's a masonry gravity structure that gets thicker at the bottom, made of low impact material called sand lime bricks, which are still available, autoclaved sand and lime, which are pretty good. They're ugly as sin, but they're good things. Laid in lime mortar, so in 1,000 years when this gets knocked down, you can reclaim the bricks. Big cavities for a plinth wall, 300mm of perlite insulation poured into there. These are ribs, what we call them, diaphragm wall, isn't it, to make it more stiff, with cork to reduce the thermal bridging. Same around cork to reduce the thermal bridging from the rammed earth wall, which is here. So this is limecrete in that same cavity, because we're going to ram on top of it, so it's going to be very strong. This is the shuttering for the rammed earth wall. Where it's seen, then we use slate waste, which is good, from a local quarry. Not this quarry, we haven't got much slate waste. You actually have to buy it, which is rather odd, but fantastic material, wonderful stuff. And then a lot of timber, and obviously if you preferably use homegrown timber if possible, and by that you're improving the environment as well, because to grow good timber you have to thin it. So this isn't black forestry like you find all over Wales and Scotland. This has been thinned for these larch trees, but it could be Douglas fir, all sorts of things. And you can see how this is now like a Scandinavian type habitat with pine martins and so on. Oak is the best, but we haven't got much of that. So this ended up being actually whitewood, which wasn't particularly what we wanted, but that's the way these jobs go. So it's glulam, and you can see here bits of metal, minimal flitch plates to join the things together in a very strong way that keeps him, the Bureau-Happold engineer, happy, and is also very buildable. So this is a whitewood, but FSC. Everything is FSC, which is the most important thing, rather than homegrown. That's slightly important. So it's a big frame with normal joists and then timber cassettes, as you can say, solid timber, which you'll see in a minute. Some of the columns are round, so we took the advantage to do this wonderful thing called entasis, to taper them to the top, which was no trouble for the glulam manufacturer, costs very little, and it just makes them a bit more elegant. And then these decks of solid timber cassettes. Nowadays this is called Brettstapel, and it's pegged together with wooden pegs. At the time that hadn't been invented, or we didn't know about it anyway. So this is screwed together, but it's the same thing. And you can span enormous distances. So this is rather like a concrete deck, but it's made of timber, solid timber, which also adds to the insulation. Because we like to see how it's made, you can actually see it in the building. These are slots for services, because we haven't got suspended ceilings. We don't like them generally, which makes life really difficult, but it's possible. Otherwise, just joists as normal. So they can span huge distance. This is 6 meters span with 150 deep timber. So there's a lot of sequestration going on here, 14 kilometers of this, so it can nearly reach to Aberystwyth. And they are slotted into the frames. On top of that deck, because it's a roof terrace, we've got 250 mil of cork, and this fantastic material cork does grow on trees, and well, they've recently done that slightly iffy but interesting all cork house, which is, I think, a very brave thing to do. But it is a wonderful material. It's waterproof, similar conductivity to ordinary expanded polystyrene, grows on trees, squash it together, makes this load-bearing material, fairly load-bearing. You can walk on it or cast a slab on it. Brilliant stuff. So we use a lot of that. And the wine industry has turned away from cork. It's now screw tops and plastic. So it needs supporting, the cork industry, otherwise we're going to lose it. So for those who like details, there's the deck. This particular one has got an angle fixing it to the glulam beam, which is here. And then on top of that is butyl rubber, 250 mil cork, then EPDM, and then we'll have a roof finishes. And this is next door in the bedroom. And roof gardens are quite nice, and not only humans can enjoy them, the sheep loved it. And then pitch roofs, fairly conventional really. These are ventilated pitch roofs with 400 mil deep I-beams, timber I-beams, full of warm cell, which is in my view the best insulation ever made. because it fills every little gap and it performs much better than it should in a way. Plus it's made from a recycled newsprint, of course, and it's cheap, very cheap, cheaper than anything else if you use enough of it. I recently did a costing to prove that it was 3/4 of the cost of doing the same U value for this building in a foam whose name we shan't mention. So it's cheap, but it's brilliant. It's obviously it's not a foam, so it's thicker, but 400mm is in here. Yeah, 400mm. That does the job. Also, of course, I-beams will span enormous distances. This is the restaurant. And then there's various, this is fiberboard, wood fiberboard, another fiberboard below for the air tightness and vapor control layer, and then services space and plasterboard, ventilation above it, because we've decided to use stainless steel as our roofing. So this is a bit of our slight weakness of modern architecture. We rather like the look of it. And stainless steel is always made of recycled and is always recycled, so it's probably the best. It's 1.5 millimeters thick, so not a lot of it. It has to be a ventilated roof. This is where I've used the aluminium, so patent glazing bar, but it's not a deep patent glazing bar, it's just the glazing bar, because it's so robust and so good and light. Fantastic. But it sits on a timber rafter, so it's not structural. So there's a bit. Walls, we experimented for quite a long time with different wall constructions. Well, as humans, we've been doing it for millennia and we still don't really know. But we were rather fed up with doing the multi-layered timber frame, which works terribly well. 10 layers all which have got to be perfect. And we rather like to get back to just one solid material like concrete, but made of nice materials, or straw bale, a mono material. That's a kind of an architectural thing that we just like, that feeling of having a one material that did everything, kept us warm, kept the rain out and so on, strong enough to hold up some shelves. These are some experiments I did with wood wall lime, but we ended up using hemp lime, which is just coming in, thanks to Ralph Carpenter in East Anglia and so on. And this firm, Hempcrete, who made a commercial go of it. I think it's brilliant. You could make it out of a better crop than hemp, probably miscanthus is better. But anyway, hemp is what we used, which is a sort of a crop that the fibers are used for industrial purposes, bar composites, plastic, BMW dashboards and things. But what's left is the hemp shiv with a lime base render. This one's got a bit of cement in it, so it goes off quickly-ish. And it's a monolithic, and it does all these things. It's got some thermal mass. It's half the insulating value, but twice the thermal mass of, sheep's wool or something else. It's hygroscopic and breathable. And we took a bit of a risk, but it was fantastic, I think. Worked really well. We did it at 500 because that gave us the U value at the time that we wanted, which was that. It's since been tested and its conductivity is slightly better, so you probably don't need to do it 500, but that's what we did. But we wanted just to shutter it up, put it into the shuttering loosely and take the shuttering away. But the contractor wanted to put up some permanent shuttering. So this is Heraclith and timber as a stud wall, so that the builders could get on with stuff inside while all this went on outside. So it made sense. So this is like a negative of the wall, and it's going to be filled with 500mm of hemp lime. There's a window negative, and there is the window here. And there on the hill is where they mix the hemp with the lime, and then it's sent down this pipe, mixed with a bit of water coming down that hose pipe and sprayed on, and it sticks mostly. You can see they lose some. They can put that back in the machine. Quite amazing, really. So they could build it out to 500mm, and then we finished it in a lime render with an earth pigment, nicely made for us by somebody in Germany to match a farrow and ball colour we really fancied, which gives this lovely rich colour. Yeah, and on the whole, it's been pretty good. It's broken down in places. Mostly it's the render that's gone wrong, not the hemp lime. In fact, that's been pretty good. Other walls are what we call external joinery walls. So all the walls of the rooms where they're looking somewhere have got daylight and views and solar gain, and ventilation is shading. So that's FSC timber everywhere. This, which I thought we'd invented, but apparently not, this louvered shutter with insect mesh and a shutter on the inside, so you can ventilate without rain or burglars or insects getting in. It's since been done much better by Archetype using a window instead, which I think is much nicer. Sliding screens for overheating. Yeah, well, this was good FSC timber joinery, but it was really very poorly made, and it'd be lovely to get some much better joinery in there. This is where our airtightness didn't work really. There you go, timber frame walls. We did do some of the conventional timber frame walls where we wanted it a bit thinner so we could have the slider going in front of it in the bedrooms. This is what it looks like from an office. Don't do stable doors, they were terrible. But here's the louver thing. You can just see a bit of light coming through there. That works very well, I think. This is my favourite wall, which is the galleries around the back to stop overlooking of basically the rubbish that there's lying around. No, it's to stop overlooking the cottages. We did this slatted screen, which I see lots of people do now, and I really like it. It gives a lovely space inside of semi-openness. Ground floors didn't work so well. Here's that plinth wall, retaining wall with the perlite insulation, hemp lime above it. You see at the time it was just going to be hemp lime. And then this is what we went for, which I think was not a good construction. It's got perlite, which the material itself is okay. And then we were persuaded to do a hemp lime screed on top, which didn't really work very well. Well, it did work, but not where you want to put timber on top of it, because we wanted timber finish. So this is Thermo Silencio, which is a fibre board with underfloor heating pipes and so on, and ash flooring. But it's got to be at a really good moisture content, otherwise the floor will go completely wrong. And hemp loves water. It's very hygroscopic, and we just couldn't get it to dry out. So in the end, we had to put a polythene sheet over and let it dry very slowly. But that was a mistake. But where we had tiled floors in the toilets, it worked brilliantly, but because it could breathe through the tile, well, not the tile, but the pointing. So here was the perlite insulation. And of course you forget, you buy all these lovely materials, hemp and sheep's wool and lime, and they all come in plastic bags. The earth didn't, obviously. Some material, wood didn't, but most of it comes in plastic bags, like food does in a supermarket. And that's a huge problem. And of course, I didn't kind of think of it at the time when we were specifying. Perlite, yeah, nice. It's just exfoliated rock. Brilliant. So we left it in the bags because, as I said, not much of this gets recycled. So it's probably better to put it underground. And it also acts as the DPC. Put it underground where it'll be for many hundreds of years, I hope. And then maybe by the time this gets done, we'll have found out how, or we will be recycling polythene, because we won't be making any more new polythene. So it's a sort of, I'm not very happy with it really, but it makes a lovely pattern, doesn't it? And so on top of that went the hem lime floor slab, which was not bad, but no, it should have been hemcrete. Probably we should have done, sorry, not hemcrete, limecrete, ordinary lime concrete with underfloor heating pipes in it. Then we could have avoided the steel, aluminium spreaders, heat spreaders in the underfloor heating. And then that would have dried much quicker, as normal concrete does. We could run the heating through it to do that. and then ready for the for this finish, which is absolutely fantastic, which is supplied by a local firm who know exactly what they're doing, fitted by carpenters who knew what they're doing, and it's beautiful. And just the right thing for Cat, because our waste, our dirt is white because it comes from slate waste. So a pale floor is what you want. So ash flooring, which is solid ash, it's not composite, is terrific. So I'm really pleased with that. We did, oh God, I've still got a bit to go. Yeah, it's not long. I'll speed up. Unfired earth blocks, pretty good. Again, wrapped in plastic because they're not waterproof. So in a way, that's quite reasonable. For all the ground floor partitions, so pretty good. We've done rammed earth before. It worked really well in the shop. So let's do it again. So it's decided in the end to do it in 4 sections. I discovered a few years after doing it, I went to Alhambra and saw this. So they beat me to it by several hundred years, but there we are. Fair dues. So here it is, but they didn't build a roof, which we wanted them to do, and I did drawings for how to do it, but they wanted to sheet it up every night, which was terrible. It took ages because you can't let any water get on this. And here it is, preparing the earth, which came from a local quarry as a waste or byproduct of a limestone quarry. It's called scalpings. So it's it's a very heavily tested in Bath for the right strength and everything, and it's rammed from 100 mil down to 50 mil. And there's the formwork that they used. Unfortunately, they tried to cut corners. I haven't got the pictures of that. Some other time I'll show you all that. And it collapsed when they took the shuttering off, and they had to redo it because they started probably at 150 mil and rammed it to 100, so it wasn't nearly strong enough. So it wasted 6 months taking it to bits and doing it again. Of course, you can use the same earth. In fact, that's what this is. This is a picture of some of the rammed earth wall being demolished and broken up to use it again. So that's quite nice, really. They, of course, were fairly annoyed, but when they did it the next time, it was really good. 50 mil, you can see the 50 mil lifts here. So it's 100 mil, round 50 mil. On top of that, wall plate, lots of timber, lots of ply web trusses, which are amazing things. And then this Eugene stainless steel, beautifully done by these people. Incredible workmanship, wonderful. I phoned them up in a panic and I said, oh, I forgot to tell you, we wanted, and he said, I know what you're going to say. You want the seams to follow the glazing and then follow up the drum in the middle, don't you? Yes, of course you do. Oh, God, why can't they all be like that? So here's David, very pleased, rammed earth walls. We wanted it left like that, but we had to fit things and people and so on, which is a bit annoying, and a bit of acoustic stuff because circles are not great for lecture theatres, but we improved it enough with the sheep's wool and so on to get it reasonable. So it's pretty lovely. And finishing on these 2 slides, because what I learned, all these materials are great, but you've got to have people who understand it. You've got to have the builders who take it on board. And our first contractor, who we thought was quite good, coming from a history of conservation, didn't at all, or at least they got taken over and by a crook. And the firm in the end went bust. We threw off site. No, it was horrible, but terrible time. But in the end, these people, this guy is a physicist and runs this small local firm with people he trusts, brilliant, skillful people who love steaming ash to make handrails to the right diameter. Fantastic. Terrific care. One of the carpenters said when I went on site, sorry, Pat, I made a mistake. Oh, God, what? He said, well, the cork expansion strip, I should have had it running up the front of the stage, shouldn't I? And I forgot. And I said, okay, we'll let you off that one. But that was the care that went into it. And I'm afraid it does take care because these materials brilliant as they are, like rammed earth, fantastic stuff, but it's friable. If you leave it in the rain, it'll all wash away, which in a way is quite good. When everything changes in a few hundred years' time, you can just let it wash down into the ground again. So that's a good thing. The ash, which is not a durable timber, will rot away, and you'll never know we've been there. And I think that's a good thing. But to do that, you've got to have people who understand these materials. And they were a brilliant contractor, I have to say. Wonderful. This is Peter Potter, the painter, who was fantastic. And he didn't take our word for it in the spec. He would phone around, make absolutely sure, do tests. He didn't want any failures. We didn't do very much painting. You try and leave things natural if you can, but you need something on the floor. And so he made sure it was absolutely the right thing. Brilliant. There's the carpenter who was apologetic, and there's the guy talking to David. So the year we spent renovating this building from the previous contractor, getting it open in 2010, it isn't finished. There were 2,500 defects, in which we did 2,000. So there's still some work to do, but it was absolutely joyous just working with these people. Oh, here's how we built it. Foundations, frame, decks, more joists, masonry, rammed earth in no time at all. All that. Cover it in something, put some walls and a bit of colour. And that's the end. These were the people involved. We were lucky to get some awards, and there, like a good academic, is my references. Thank you.
Wow, Pat, just amazing, just absolutely amazing.
Did I go over? Yes.
No, don't worry. I by the fact that there's only 10 people that have left, it shows how very interested this audience is in what you've got to say.
They were all from Kingspan, were they?
They left quite late on, so they must have taken a fair amount of punching if they.
All right, okay. Shall I stop sharing?
Yeah, that'd be great.
Stop share. There you go.
And thank you again, Pat. Thank you for your honesty. My favourite quotes so far that you've said were, "Buildings are not that hard." Great.
No.
Not
really, are they?
Not really. You architects are really good at it, so get on with it. And then a few ones which were, unless of course you were from CAT or knew about CAT, it's just a thing that David and I have. And me and David have a rule that every room should have a view. For those of you who don't know, that he's speaking about David Lee.
Yes, David Lee. He's an architect. Yeah.
He's essentially your partner in crime, practically.
One quote I forgot was, I was going to say, perhaps at the beginning, perhaps doing less is more.
Damn
it. Okay.
A missed opportunity. You got it in the end, though.
Yeah.
So, Georgie, we've had a lot of questions. I don't think we necessarily have time for them all.
We have, yeah. So I was going to say that I think we'll probably do just one or two, because I think we've only got until about 10 to 7. But if you're okay with it, we'll probably just send you a list of questions if you're happy to answer them.
Yes.
Okay, so I'm going to start. I'm just going to pick. I'm so sorry if I don't pick your question. So there's one from Rob Neild. He said, "Great talk, and fully agree with using more stone and timber for building structures. As a structural engineer, I design many buildings with these materials, but also too many where there are disregard, either because deemed too risky or costly. How do you find the task of getting clients / design teams on side to use low carbon materials when there is no current legislation to force clients and designers to reduce CO2?
No, you're quite right. Yeah, how do you do it? I mean, I live a charmed life, I'm afraid. Is that people come and ask me to do it. So I'm not a very good person to answer that. It is sometimes, yeah, okay. As I sometimes have discussions with clients about the best thing to do, and I have to leave it to them to decide, really. I have to point out exactly what I think about some materials. And if they disagree, well, that's absolutely fine. One of the nicest things in the world I've found, I've only done it 3 times, is to refuse a job. Gosh, it's terrific. If you can afford to do it, it makes you feel loads better about yourself. But sometimes it gets to a state where you have to say, I just can't go on. Anyway, yeah, but that's rare. And that's the trouble, really. We're all so desperate for work that we take on anything. And, you know, architects are viewed as sort of building prostitutes, aren't they? They'll do anything for money. I'm afraid that's the public perception of them, which is not without its truth, I think. And I think we've lost an awful lot. We've lost respect. And one way to get that back, I think, is to be bloody minded about things, or just tell as much as you can the truth. And they're not always more costly. That's the odd thing. And they found that with Passive House. You ask architect, are Passive House good? No, they're not more costly. And they use some very nice materials. Some I don't agree with, but mostly really nice materials. So it is possible. Some things like that flooring I showed at the end, the ash flooring, was cheaper than buying, and I can't remember the makes, but the sort of standard, not the composite, but the real timber flooring that you get from Germany. I can't remember. But anyway, because we bought it locally from a firm who knows exactly what they're doing, they work out the moisture content that will be just right for you. And it is. We haven't had it buckling or shrinking. Brilliant. So it's up to you to specify things that are not necessarily more costly. Sometimes they are, of course they are. You know, with quality comes cost. And I am talking about quality because I think that there is a qualitative difference between these buildings. People come into Wise, and I mentioned smell, maybe it's to do with that, but they go, oh, and that kind of costs something. It's a better quality building than you otherwise would have got in a normal university where you go into a lecture theatre and you think, oh God. So how do you compare it? I'm not sure you can. Anyway, thank you for the question. There is no legislation to force people. No, you're right. It's pathetic. Somebody mentioned earlier about new Part Ls, and obviously Future Home Standard, somebody's mentioned, embodied energy or carbon has got to be in there. It's ridiculous. You just do a graph, the amount of energy goes into making a passive house, say, and then the amount it uses, it takes at least 20 years before you use the same amount of energy it takes to build it. So obviously it's important, and that's now recognized in the passive house world. There's even add-ons to PHPP and so on. Okay, what other question would you like? There's loads of them.
There's so many, isn't there? I was going to add to that actually, is that Archetype did an amazing graph last year that in one of our first lectures, where they basically just drew up, you know, these are the different options if you were to choose to do a retrofit, new build, and passive house, everything else. And they almost, in a simple graph, gave kind of embodied carbon, economic reasons, and everything they needed to, and a couple of simple graphs to a client, and said,
yeah,
benefits, now it's your choice.
Okay, I'll try and get hold of those graphs.
Yeah, I know. I think we all are.
They're very, fortunately, we've got, I think, 4 of our ex-students, or 5 even, working at Archetype Hereford, and a couple in London, so I should be able to get it out, I think.
Yeah.
If anyone could, Pat,
and then
I'm sure
pass
it
it
would be you.
I'll pass it on.
Yeah.
It must be, it's public interest. Yes.
Exactly.
Oh, somebody's asking about mycelium bricks. Oh, yeah, that's very interesting, isn't it? I have no, I might have some mycelium for supper, but I have no actual experience of them. And it looks amazing, the work they're doing. Yeah, I mean, it's just one of those wacky things that might just be really good.
We've been talking about it for a while as well.
Yeah. No, people have done loads. I haven't tried mycelium bricks yet, but yeah.
Yeah, just got a light-hearted question, if that's okay. Josie Turner has said, is the rammed earth tower outside still standing?
Oh, Josie, hello, how are you? Lovely to hear from you. Yes, it is. That's very interesting. What I call the sentry box that you built, and you mixed all the, yeah, let's put it where it is. Josie mixed all the earth up at the right consistency and right moisture content. Well done. Yes, it's still standing. I mean, it's very interesting because it's an external exposed rammed earth wall in an area of high rainfall, i.e. Machynlleth.
Okay, Wales.
No, not all Wales. That bit of Wales on the west coast is wet. And yeah, it's looking great. Thanks, Josie. We tried, as you know, different techniques with the little slips and so on, like we've seen in the books, but it looks terrific. Yeah. So I'm less worried about external rammed earth walls now. Maybe you don't have to put cement in them as the Australians do, or other people have done who we shan't mention.
I think that's the thing though, is that they try and get it to a certain height, don't they? And make them taller and taller. So they add little bits here and there just to create some reinforcement. But
Oh no.
well,
Look, that's 7.5 meters tall.
Yeah,
that
exactly.
one at Cat. How much taller do you want to go? The hammer is about the same size. I've seen 5 or 6 story rammed earth gompas in Nepal. I mean, just make it thicker.
Yeah. I was going to say, do you want me to ask any more questions?
Yeah, I do. Yeah, I've got nothing to do.
I think. Oh, well, okay. Go on, ask one more, and then I think we'll probably wrap it up because I can see that.
I'll do one more. Okay.
Want to respect Bill's time. Pat, I'm sure you could talk all night.
I could. I've got a glass of wine now, so yeah, I could. So, cheers.
I was going to say, where's that glass of red?
So this one's from John Christopher. He says, thank you, Pat, for a fantastic talk. Although timber, green oak from a local tree, is renewable, local and possible even carbon negative in our time of climate crisis, is it now even more carbon negative to let the tree grow?
Very interesting and worthy of about 3 hours of discussion. Right, trees are best left where they are. That seems the conclusion. Let them absorb carbon. Like even mature trees, if you look, they put on this tiny little bit, but that's an enormous amount of carbon. So generally leave trees where they are. Hold on, it's telling me I've got a meeting, but I'm not going to go. But some recent work, which was quoted by the Woodland Trust, is that of the carbon absorbed by a tree from carbon dioxide, sequestered, if you like, 70% of it is underground in the soil. So when you cut a tree down, that's you got 30%, you waste maybe half of it. So you're using 15% of that carbon. So if you don't dig the ground up and plant a new one, which releases a lot of carbon, if you leave it, and if you use a tree that coppices, of course, that would be great because you've left all the root structure, which is another 10% or something, plus the soil, and then you're setting it off again with a new life. If it's, however, a conifer, then you kill it, don't you, when you cut it down? But it's important that if you replant, you do it very carefully. You don't go through those enormous plows like they do and dig up the roots. You should leave the carbon where it is and then start again. It's pretty complicated, really. Yeah, as you can tell, there's a lot of science in it, but it is really interesting. And it's, all to do with this ridiculous thing of counting it as a negative carbon when you put it in a building. As I said, if many of my buildings, that makes them negative carbon. It's better that I keep building these things and slowly, it's ridiculous. So it's done to give you credit for putting in carbon sequestration into the building, which is obviously a good idea. But I don't think you should count it in a sort of, adding up, taking away type of way. Just count the energy that went to make the straw bale and the sequestration thing is a bonus, in my view.
Well, thank you so much, Pat, and thank you,
Okay.
Georgie, and thank you, Marina, and thank you, Katie, who for an amazing talk. Just a quick shout out again, a thank you to our sponsors who this wouldn't be possible without. So, Alamir, our patron sponsor, All Good, Altro, Ipstop Bricks, Kitchen Gallery, Millican, Rainers, and Taylor Maxwell. So thank you again, everyone, and apologies for overrunning, but I think we can all agree that was an amazing talk. So thank you again, Pat. And,
I just looked in the chat, Matt.
uh-oh.
The ones that left are ex-students. Fair enough. Fair enough. There's Seb, there's Miguel.
Yeah, I was noticing that. So hi, everyone. Hi, old ex-cats or kittens. But yeah, thank you, everyone. So good
Bye.
evening. Thank you. Cheers. Bye-bye.
Bye.